All right, let's take a look at review problem 2.7. Let's determine whether these are true or false. The first one is false. The reason this is false, this is stipulating that for every real number x squared is greater than or equal to 1. That is false because if x equals 0, then x squared is not greater than or equal to 1. Is not greater than or equal to 1. And so that one is false. For the second one is true. Now this is true because I just simply need to find a value of x that works, which is simply saying there exists an x. So if I take, say, 2, then 2 squared is indeed greater than or equal to 1. And so there exists a value of x that works. However, it's not true that for every value of x it works. This next one, for every value of x is greater than or equal to negative x. That is false. For example, if I take x is equal to negative 1, it is false that negative 1 is greater than negative 1. So this is a false statement, even though it looks convincing that x is greater than or equal to negative x. This next one is true. There exists an x that makes this work. In fact, the x is unique if x is equal to 1/4. So if x is equal to 1/4, then indeed the left-hand side is equal to 6. Next one is false. For every x, 5x is greater than 4x. Once again, if x is a negative number, it is false that 5 times negative 1 is greater than 4 times negative 1. So that's false. This one is false, that there exists a value of x such that absolute value of x plus 1 is equal to x. There's an algebraic argument for this, but perhaps the easiest argument is a geometric argument. The graph of y equals x looks like this, whereas the graph of absolute value of x plus 1, the graph of absolute value of x looks like this. So the graph of absolute value of x plus 1 will look like this, where these are parallel. And clearly the line in red does not intersect the black graph, and so there is no solution to this equation. This can also be done by separating into positive and negative cases. If x is positive, then I have x plus 1 equals x. So I'll write this out. If x is greater than 0, greater than or equal to 0, then this becomes x plus 1 equals x, and that can't happen. If x is less than 0, then I get negative x plus 1 equals x. So 1 equals 2x, and x equals 1/2. That looks promising, except that x is supposed to be less than 0, so that can't happen either. So this one has no solutions. All right, next example. There exists an x such that for every value of y, x plus y is equal to y. There exists an x such that for every value of y, x plus y is equal to y. That is true. If x equals 0, then 0 plus y equals y always. So there is a number such that this equality always holds. There's a number x, so that equality always holds. So that's true. The next one is false. For every value of x, there exists a y such that x plus y is equal to y. That's false. So if x equals 1, then 1 plus y is clearly not equal to y. So that can't be true. Next, there exists an x such that for every value of y, x is less than y. That is false. And basically, there is no smallest number. This is saying that there is a number x such that every number y is bigger than x. That can't happen. However, the next one is true. For every value of x, there exists a y that's bigger. So for every x, there is a number that is bigger, that is larger. And so that is true. For example, if y is equal to x plus 1, then clearly y is bigger than x. So that always works.